There's actually a lot of science and technology that goes into stone tools, and that's not to say the people who were making them sat down and thought, I'm going to approach this from a scientific perspective. But there's a lot of knowledge that goes into making stone tools, a lot of traditional cultural knowledge that's passed down, from the person doing it to people learning. So one of the things you have to know to start off with is what kind of rock makes good tools. So most of what you see here that I have is obsidian. It's volcanic glass. It makes great stone tools because it's glassy. There's lots of other rocks. This one is a fine-grained basalt, and I'll explain why you can use something as different as obsidian, fine-grained basalt. But cherts, flints, jaspers, agates, petrified wood, anything that is fine-grained enough, or in the case of obsidian, it has no grain, but it's fine-grained enough that it will break the way I want it to break. So for making chipped stone tools, which is what I'm going to show you, I need a rock that I can control the breaking of. So something like granite that has big crystals in it, granite makes great stone tools if you grind them out. It makes lousy chip stone tools because you go to take a chip off and you get a chunk. Okay, so think of the way like concrete breaks versus the way glass breaks. So first thing you need to know is what kind of rock can make the stone tool out of, and where does that rock occur? Because all over the world, not just in Washington, you don't get tool quality rock everywhere. Like I could go out here and start wandering the streets of Redmond, and I'd probably be wandering for a couple hours before I found a tool quality rock. And if I did find one, it would probably be a water-worn piece of gravel washed down by a glacier or one of the streams. So you got to know the right kind of rock. You got to know where to find it. People would travel miles to get the right kind of rock. They would trade it over hundreds of miles. This obsidian's from Central Oregon, where it's very common. There's very little obsidian here in Washington. Even though we have lots of volcanoes, the volcanoes just don't make it. However, we have a lot of cherts and jaspers and agates and things like that to make stone tools out of. So you've got the right kind of rock to start your tool with. You need the right tools to make it with. I'm going to show you a technique that's called percussion flaking. I'm going to hit my raw material with a hammer of some kind. I have a couple different hammers. You can use hammer stones. This is an antler hammer. The difference is partly cultural. It's partly what you want to do with the stone tool. But the other thing is you do have to know the right kind of tool to use. And a lot of people, when I start doing this, kind of think, oh, if you're going to break a rock, you need a really hard hammer. And it's kind of counterintuitive, but you actually need a really soft hammer. So this is a very soft limestone rock. Antler's not very hard. I could do this with wood, like a wooden hammer, if I had it right. A really hard hammer tends to shatter the tool, not flake it. I mentioned this is a learned cultural behavior. I learned how to flint knap with hammer stones. So I had the antlers, but I'm really bad at making them with antlers, so I'm going to use my hammer stone. The technology is you've got your raw material that breaks in a certain way. You've got your tool to make it, and then you need to know how to break it. How do I get from, this is a chunk of obsidian, you can see it's weathered. This is where it's been sitting on the surface for 100,000 years. That's what it looks like on the inside. It's nice and glassy. How do I get from a thick, lumpy rock to something like that? That's thin. This one's not finished yet, so ignore the bottom, but relatively, even in size, could be used to cut and things like that. The technology is there's a lot of physical constraints to the rock. So making stone tools is what we call a reduction technology. It's not like making baskets or pottery, where pottery you take clay, you build it up, you make a mistake, you smoosh it back down, you can build it up again. Basketry, you're weaving it. If you make a mistake, you can unweave it a little bit and fix it. In making stone tools, I'm going to reduce this block to a tool. I'm going to chip away at it. So I can never make a bigger tool than the rock I'm starting with. So that's another constraint on the technology. If I want to make a big knife, I have to go find a big enough piece of rock. If I want to make a little arrowhead, that's this big, I can use different kinds of rocks. The rock itself behaves in certain ways. So I like using obsidian, this volcanic glass, for demonstration. technically glass is a liquid. It has no internal structure. That means there's no cleavage planes like diamonds have. If I hit it, what I'm going to be doing is hitting it with my hammerstone to direct the force to take off the chips. Because there's no internal structure, I can direct which way the chips go within certain physical limits of the rock. So I'm going to start here in a minute, but you'll see. I know, for example, that if I hit right here, I can take a big flake off. If I hit right here, just 2 inches over, I can beat on that spot all day with my hammerstone, and I will do nothing except eventually shatter my rock. And that has to do with the angle between where I hit it and where I'm taking the flake off. And people have written just hundreds of pages, probably thousands of pages of engineering dissertations on what exactly happens when this rock contacts this rock and starts a fracture. Don't need to know all that. All I need to know is if I hit it here, it works. If I hit it here, it doesn't. I also know that if I hit it here, because of this surface of the rock, I'm going to take a big flake right off the front. And it's knowing how that rock breaks and knowing how to control it that gets you from this to this. Okay, so, for example, I'm going to hit this here. And if I do this right, I don't know if you can see that, I'm going to take off a big flake just like that. And I know it's going to be that shape because I've done this long enough to know that the characteristics of the rock, the way that force travels through, that's what it's going to do. So this is really a matter of, like I said, it's not carving the rock, you're chipping it. It's a matter of doing controlled ripples through the rock. So think of it, every time I hit the rock, it's like a rock hitting water. Force goes out and it goes down. So I'm going to make a cone shape. Except since I'm hitting it near the edge, I'm going to make half a cone. And you'll see what I mean here in a minute. Even better than that. So long, flat rock. I also know that the reason I got this really wavy end was I didn't hit the rock hard enough for the size of the flake. I hit it too far back, I took off too big of a flake. That force, that ripple traveled through, and then it started to peter out, and it kind of started waving, and I'll fix that. But now, instead of a big, flat, knobby rock, I've taken that part off. There's another tool waiting to be made. Now I'm thinner. I'm going to keep doing that to get it to a point close enough where I can start putting an edge on it. The other thing with making stone tools is every time you take something off, you are changing the shape of the rock. So you're changing how that force is going to travel through the rock. So this flake was bigger